Finding Bebot's treasure. Throughout the various learning experiences, children will learn about various digital systems, including hardware and software. Children can do this through exploring basic robotic technologies. Children will learn about directionality, movement, and location, linking to mathematics and geography learning. In the initial learning experience, children will focus on robotic roleplay. This will build upon their prior knowledge and understanding of direction and movement and help them with further learning experiences. In the second learning experience, children will begin to explore the Bebots. Children will have the opportunity to freely investigate the controls. This will help children to make connections to the previous learning experience and build upon their knowledge of directional vocabulary, software, and hardware. In the third learning experience, children will be given a map and will need to navigate the Bebots to the treasure. From this, children will build upon their knowledge and understanding of software, hardware, programming, and directionality. In the final learning experience, children will create their own maps and algorithms. This activity will allow students to apply their knowledge of coding and debugging as well as their mathematical and geographical concepts.
Computational thinking is a process that allows us to think of complex problems in a way that can be resolved by a computer. There are many different computational thinking skills which include anything from problem representation to problem solving and productive attitudes towards failure. Computational thinking can be divided into 3 dimensions: concepts, practices, and perspectives. All of these dimensions come together to form the foundation of digital technologies which can be applied across disciplines. Throughout our teaching sequence, children develop knowledge of computational thinking concepts when developing an understanding of sequencing through the sequencing of steps to navigate the Bebot. Students also develop an understanding of computational thinking practices when they experiment with the Bebot and test different algorithms to see which one gets the Bebot to the desired location. When experimenting with these algorithms, students often need to engage in a process called debugging, where they have to identify and remove errors within their algorithm. Students also develop computational thinking perspectives when answering and asking questions throughout the activities. Students will also get a chance to develop these perspectives when expressing their ideas and connecting with the resources available.
This learning sequence also helps to enhance the students' understanding of coding. Coding is a form of digital literacy which involves inputting instructions into a machine or robot. As we know, children learn best when they are engaged in hands-on and interactive learning experiences. Therefore, as 21st century educators, we need to teach our students to code in an engaging, play-based way. In our first activity, the children are starting to learn the basics of coding without using technology. This way, they're starting with their known world themselves, and then moving on to the unknown, which is the Bebots. In the second activity, the children are introduced to the programming language of the Bebots. They explore the concept first by testing out the different buttons and commands. Then the teacher explicitly describes to the class the 7 different commands: forward 15 centimeters, backwards 15 centimeters, left 90 degrees, right 90 degrees, pause for 1 second, go, and clear. In the second part of activity 2, and in the last 2 activities, the children are applying these different commands to investigate how to get the Bebot where it needs to go.
An integrated approach incorporates numerous disciplines into the same unit of work. Integrating numerous subjects allows students to learn in an engaging way that links to real-world experiences. Integration of geography and mathematics with digital technology creates hands-on learning experiences that deepen students' understanding of particular skills. The activities incorporated within the unit provide links to STEM, specifically mathematics. Mathematic concepts are explored throughout all activities planned in this unit. Students develop their understanding of directional language with and without technology. The fourth activity incorporates the geography concept land features. Students draw a variety of land features and use the digital technology, in this case Bebots, to get from point A to B. This activity provides an integrated approach incorporating mathematics, digital technology, and obviously geography. Finally, throughout the unit, students are required to verbally give and explain directional steps, developing their literacy skills. These verbal directions were presented in small groups or directly to the teacher for assessment.
It can be seen that an integrated learning approach incorporates various aspects of the curriculum and engages children in hands-on learning.